The purpose of this lesson is to learn about the history of computers, about assembly and machine language, high-level programming languages, compiling and the just-in-time compiler, the common language runtime and portability, a timeline of more prevalent programming languages, the history of C#, and how to install Visual Studio and C#. A computer has three main functions: input, processing, and output. Input is getting data in from a user or from some sort of external sensor or device. It could be a keyboard or a mouse. Then you have the processing, which is taking that data that it receives, doing something with it, and then providing data back to the user or to some sort of file. Output is after the data has been processed, things will be presented on the screen. That's an output device, or a printer is an output device, or even the hard drive is an output device. Alright, so each processor has a list of commands that it's actually able to support, and this is called the instruction set. Many of the different types of processors have instructions that overlap each other, which means that I could have an Intel processor or an AMD processor, and both of those may have the same types of instructions, but there's a possibility that the Intel has additional instructions or less instructions than what the AMD processor has. So what we need to worry about is when we design programs, we have to know what the instruction set is that each processor is capable of handling. Like I said, some of them allow you to have additional commands, some don't have as many. Some have old commands that aren't used anymore strictly for legacy support. There are some processors out there called RISC, or reduced instruction set processors, that only have the instructions that are actually required by the operating system. There are no additional, no legacy, no extra commands. Only the ones that are really actually going to be used by that operating system. Now, those are typically going to be faster because the chip only has the commands that are actually needed by the operating system, but it does not necessarily have legacy support for older applications. There are also other ones called complex instruction set computing, and those are CISC chips. And essentially what that means is that they have all of the possible instructions that could be sent to them. It could be legacy or even things that will be used in the future that aren't fully implemented yet. We have these things called high-level programming languages. Now, high-level programming language is going to take something that I type into the computer, the code that I type in, which is called syntax, and instead of doing something like telling the computer to modify a memory location or to turn a switch on or turn it off or things of that nature, what I'm going to do is I'm going to type commands in, and I'm going to let the system interpret what I mean by those commands, and in turn let it turn around and actually manipulate the processor and the memory and everything. So I don't necessarily need to worry about exactly how the system actually handles those commands. I just need to know what kind of commands it actually supports. This is what we're going to see for any of our current day programming languages. We need to know the syntax that is supported by the programming language, and then the programming language behind the scenes will perform all the calculations and all the functions that we need without us having to worry about it. And the only thing that we need to worry about is each programming language will have its own syntax, and it will have its own commands that they're able to handle. These are all going to be typed in by the programmer. After I type the code in, the system then has to turn around and generate the machine language. So it's going to generate the assembly code that is going to turn around and physically manipulate all the switches on the processor, manipulate the memory spaces, and so forth. This process of taking a high-level programming language and converting it into machine language is called compiling. Now, what will happen is when I compile the code, I actually take the syntax that I type in, which is just English language, and turn it into an executable binary file. The binary file is then what is actually processed by the system, and that's what actually turns around and actually is able to do anything with the processor and the memory. So I type the syntax, I type it into a programming environment. When I compile it, it takes whatever I typed in and it turns that into something that the processor would actually understand. Each programming language is going to have its own requirements for compiling a program. Most of the programming environments will come with a compiler, which is just simply a program that's responsible for doing this process for me. It automates it so I don't have to build the compiled version. Some languages do not. Alright, so in the old days of computing, it was necessary to write a program geared towards every single processor that you were going to use. So if I wanted to write a program that was designed for an Intel processor, and another program that was designed for an AMD processor, and another one that was designed for Spark or whatever other processor was available at the time, then I had to write a completely separate version of my program for each one of those processors. So my program had to know how to interact with each processor that was out there. So this led to one of two main scenarios. One was, I'm going to limit which processors I actually support for my program. So it used to be you would see on the back of the boxes when you bought a program what processors were supported, and if it wasn't in the list, your program wouldn't work. You couldn't use it on your computer. The other option was, and this would be for your bigger programs, ones that were more popular, usually commercial applications that were more expensive and had a large development team, was to maintain code for every single one of those processors. So that way I have a code for the AMD, I have the code for Intel, I have the code for, at the time we had Cyrix, and we had a bunch of other processors out there. Well, this is very developer and maintenance intensive. It's not necessarily what's desirable, but it was more common than not, because if you wanted to build an app and get everybody to be able to use it, then your application had to work on as many processors as possible. You can tell very quickly that this is not really ideal, because I have to maintain 7, 12, however many different versions there are, depending on how many different processors there are, and not necessarily just by brand, it was also by product line. So if I had a 386 or a 486 or a Pentium, I had to maintain the code for each one of those processors because they had different instruction sets. So this led the way to what we currently see, which is called portability. Now, we hear people talk about porting a program. What that means is that I'm going to write the program for one platform, maybe for Windows on an Intel processor, and I want to turn around and make that exact same program work on a Linux computer that is running on an AMD processor. Once again, I used to have to build the separate application for those environments. Nowadays, what we can do is we can build what's called a portable application. Now, when we say portable, this is different from what you've experienced as portable apps on the internet. What this means is that I'm going to build my app in one programming language and then turn around and allow the system to automatically generate something that will work on different platforms. Alright, so there are two main ways that I can do this. I could have automated compilers, so my system, I could tell it all of the different platforms that are going to be supported and let some automated compiler build the executable binaries for every one of those platforms. Or what we actually now use is called the Common Intermediary Language, which is just simply an interpreter. You've probably used Java before, and Java is one of the biggest known programs to do this. Java, what it does is you build one application in Java, and then any computer that has the Java runtime environment installed on it, whether it's Windows, a Mac, if it's a car stereo, microwaves run Java, I've seen refrigerators, all these different devices, all you need is for the runtime environment to be installed, and your program will work. You don't have to do anything different as the programmer. All you have to worry about is that the Java runtime environment is installed on all those computers. So what that means is, in the case with Java, Sun, which has now been bought out by Oracle, they maintain the runtime environments for you. Well, in this course we're going to be using C#, which is a function of Microsoft Visual Studio, which is a subset of what's called the .NET framework. Now, the .NET framework is developed by Microsoft. It is designed for Windows, but there are versions of .NET framework that will run on other systems. So I can actually get a .NET interpreter to run on Linux. And what that means is that I can build one application in C#, and I could get that to run on a Windows computer or some Linux computers, and it doesn't matter what processor I'm using as long as that computer has the .NET framework installed. So what I need is I need the runtime environment, the CIL. I need that to be on the computer for me to run my program. If it's installed, that's all that I need. Alright, so we have this thing called the just-in-time compiler, and what this is that when I write my code in the programming language, I'm going to debug the program, which means I'm going to start the program, I'm going to try to run it, make sure that it actually works. And when I do this process, what it actually does for me behind the scenes is it builds an executable file. Now, unlike our machine language executable files, these executable files will run in what's called a virtual machine. Now this virtual machine, it's different than virtual machines if you've used them for operating systems. This is a little virtualized section of the processor it's actually in the operating system that we're going to send the program to. So the executable runs in this virtual machine environment. So what happens is our runtime environment runs our executable, and the runtime environment, the .NET framework, turns around and it's the one that's responsible for actually talking to the processor. So this thing is called Common Language Runtime, and it allows my executable binary file that was written on Windows with an Intel processor to allow that exact same executable file to run on somebody else's computer that's running, say, Windows 7 on an AMD processor. I don't have to worry about what platform it is. I just have to make sure that the .NET framework is installed. So the benefits of this are we have performance improvements, which means that my program runs no matter what platform I'm on. It's going to run just as well on an AMD processor versus an Intel processor. All I need to worry about is getting it on the system and the .NET framework there. Okay, I also have the ability to do what's called hyper-threading. So I can take multi-threading, which is taking multiple things and making them run at the same time. This also allows for more scalable applications. What this means is that I can take my program that was designed to run on one computer and I can put it in a virtual environment on a server that has, say, 4 or 5 or 8 processor cores, and then what it will do is it'll automatically scale out to all the processors that are there. So my single core processor program will automatically scale because I only care about running it, and then the .NET framework handles all of this performance stuff for me. Now the other thing I can do is I can write part of my program in C#, I can write part of it in C++, I can write part of it in Visual Basic, and because all of these programs are going to talk to the .NET framework, they can actually all run and they can all interact with each other through the .NET framework. It's our interpreter. So I could write a program 10 years ago in Visual Basic, write another component that has to interface with it in C#, and the two of those can actually talk together. We also have this thing called garbage collection, which is when I write things like variables or I make objects. Well, what happens is they tie up room in memory. Well, I no longer have to worry about what happens in the memory because it's up to my high-level programming language to take care of that for me. So the CLR will actually, behind the scenes, delete those objects when I get rid of them. If I no longer need a variable, it will clean up the memory space for me. So it actually handles memory better also. The other thing that allows for me to have is what's called structured exception handling, which means that in old programming languages, if you ask the user to enter a number and they entered a text string or something like that, it would actually cause the program to crash. Well, exception handling allows me to pick up exceptions, errors, and do something with them. So if, let's say, the user enters a name in a field where they should be putting a number, we can actually provide an error back to them and say, hey, you should have entered a number, please try again, and then that way it doesn't actually crash the program. So some things that you need to know about. We have programming language. That is going to be the set of rules, which is also called syntax, that's used by a high-level programming language. That's the environment that we use to actually create these binary executable files. Syntax is going to be what I actually type in. These are the instructions that I have to know, the commands that are supported by the programming language, and that's what I will actually type in. Debugging is going through my program after I've created it and trying to figure out what is wrong with it. Because a lot of times we're going to create our program, we'll run it, we'll get an error, we have to go back and fix our error, then we fix it, we try to run it again, maybe we get another error, or something doesn't work necessarily the way that we want. And debugging it involves not only trying to fix things like I typed something wrong or I used the wrong command, but also things like I used the wrong logic. Maybe I wanted to add something instead of subtracting. So debugging is the process of going through my code, going through my program, making sure that everything works the way that I want it to. After I debug my code, I'm going to compile it, I'm going to run it, I'm going to create an executable binary file, and the compilation of it is where it will actually build the executable binary file, the one that can be interpreted by the just-in-time compiler to run in the CLR. And so when we compile it, we get our executable. We have our development environment. This is typically going to be some form of a text editor. This is going to be where we will actually type the code to make up all of our programs. We're going to type the syntax, design the entire program. The thing is a lot of our programs we can actually design in a basic text editor like Notepad, but some of the things are going to be much easier to do if we have automated tools available to us. So we also have these development environments called an integrated development environment, which is also called an IDE. And this is a programming environment that gives us all of the tools that we need to be able to build our complete program. So we'll have the text editor, we'll have things like drag and drop objects. We can drag buttons, we can drag text fields and things like that. And the one that we're actually going to be using for this course is called Visual Studio. So throughout the years we've had quite a few major programming languages. There are a lot more than these, but these are some of the more common ones. Back in 1954 we had a program called Fortran. And then in 1959 another one called COBOL came out. Now these are older high-level programming languages. They were very basic in what they could do. And the reason that we need to know that these are here is we still do things that are based off of these older programming languages. So in 1964, another one called BASIC came out, and this one actually took off because it had a lot more functionality than either Fortran or COBOL. Now, 1970 comes along, you have Pascal comes out. This was made more for the scientific community, but it was designed for more robust numerical computations. The C programming language came out in 1972. It was developed by Bell Laboratories. It was actually developed as a project for the government and for the telephone system. 1983 we have Objective-C comes out. This is used for all of the Apple applications. C++ comes out. It takes C and adds object-oriented environment to it. Now it's a little different than what we expect now out of an object-oriented programming language, but we'll get more into that later in the course. But C++ started having things called events and objects that we could call and reuse code. 1987, a programming language called Perl came out. Now this one was really used as a gateway programming language to be able to use things on the internet. So if I wanted to do things like send email messages, if I wanted to be able to do chat or anything else like that, if I needed an interface for one of my servers, then I actually could develop it in Perl. Later on led away to a common group of instructions called CGI. In 1991 Python came out. Now Python recently is taking off because it's very easy to use. It's very robust for developing websites. It is also used for developing Windows applications. It's used on Linux, Mac, so it's also OS independent. It has a bunch of different operating systems where it'll actually work. 1991 Visual Basic also came out. Now this was the advent of what we experience now as Windows Forms. So when you have a Windows form where you have buttons on it and you have a text box and you all use to type things in there, you have timers, all of that stuff became real easy to use in Visual Basic. Before that you would have to actually type the code for every single object that you had. 1995 Java comes out. Java is a huge hit because it's very easy to program in, it's very robust. Once again, it works on a server, on a website, so you could actually build an application on the server. And it also had a client-side version that could run. So I could make an application run on a website and what's called a servlet that ran on the server and actually interacted with something on somebody's workstation. In 2000, Microsoft came out with C#. Now C# was designed to fix all of the problems that Microsoft perceived, all of the limitations that they perceived in C++. Now over the course of the years, C++ has actually had several iterations. There have been new revisions to it, new features have been added, but basically behind the scenes, Microsoft decided that C++ was not quite as robust, not as refined as they thought that it should be, so they decided that they were going to take on the project and design a much better programming environment. So Microsoft wanted to fix all these problems in C++. It became Microsoft's premier programming language for the .NET framework. Now if you notice, it came out in 2000, and here we are 15 years later, and it's still not necessarily the leading programming language out there. Visual Basic is actually still used more often by new programmers than C# is, And then there are other programming environments that are used even more than C#. Now it is catching up. It is becoming more prevalent. As more people learn how to use it and all the features that are in it and how easy it is to use, you will start seeing more people using it. It was designed to be portable, which means that if somebody already knew how to develop an application in C or C++, then they understood the basic constructs of all the syntax for C#, and it would make it really easy for these people to learn it and then also be able to take the application and port it to other languages. Now, Sun and Java developers claim that it is a clone of Java, but over the years, the two of them have actually gone their different ways. They've become very dissimilar to each other, but they still share the common object-oriented programming language environment. Alright, so to install C#, we actually need to download and install what's called the Microsoft Visual Studio for desktop. We're going to use the Express version, which is the free version. It is designed for students and for non-commercial use. So we're going to use the Express for this one, but if you do work for a business, you will need to get the professional version, which there is a cost for. When we download the Visual Studio Express, then we also need to download the service packs available for it immediately, especially if you have a newer computer. So what we'll do is we'll download we'll download Visual Studio, then we'll download the Service Pack 4, and then after we download those, we're going to install them. Now, it's going to check for some updates. Afterwards, we want to make sure that we keep running Windows updates over and over and over again. You want to do it until you run out of updates. So that's called running Windows updates exhaustively. And the reason for it is there are a large amount of security updates, a large amount of enhancements that have been made to it, and you want to make sure that you get them all downloaded and installed before you try to run C#. Alright, so what I've done is I've opened up the links that are in the PowerPoint presentation, and you can also search for it. If you just go online and you search for Microsoft Visual Studio Express 2012 for Windows Desktop, that's the catch to it, is you want the Windows Desktop. Otherwise, there are other versions available for you to download, and we want this one. Alright, so what we're going to do is we're going to download the desktop edition. This is a very large download, so plan on giving it some time. Download this, and then you're also going to download the Visual Studio 2012 Update 4. Now, this entire file is several gigabytes in size, so make sure that you have fast enough internet speed and also enough room to store these files. So I'm not going to show you the download because they will take a long time, but when it's finished downloading, we'll come back and we'll go and do the installation. Alright, so what I've downloaded are two ISO images that contain the executable. You can either burn them to a CD or DVD, or the other option is to extract them with something like 7-zip, or if you have Windows 8 or above, you can actually just simply mount the ISO image and access the files directly. So in this case, it's an ISO image that's inserted as our D drive. I have my WD Express full. I'm going to go ahead and run it. And this is the actual installer for C#. When presented with the screen and where to install it, you'll notice that the setup does require 4.3 gigabytes of space, and you do need to agree to the license terms. It's up to you if you want to join the Experience Improvement Program. Essentially what this means is that you're going to send information to Microsoft about the installation of the package. They'll get information about your computer. They won't take any personally identifiable information. It's just information about the install on your particular computer. Alright, so I'm going to go ahead and install it. It will take a while for it to install because it does have to download other components from the internet. So do expect this portion of the installer to take several minutes, if not tens of minutes, for it to actually download and install everything. As you can tell by the clock, it has actually taken quite a while to do this part, so please expect this to take quite a while to do the installation. It has to download everything that it needs, and then it does the installation, and that very easily can take a while. Alright, so the option here is to launch it, but I don't want to launch it yet. What I need to do next is I need to install the service pack. So I'm going to remove the disk that's in right now and put the disk in for the service pack. If you're using Windows 8 or above, you can just simply mount the disk. Alright, so now that the disk is in the drive, I can install the Visual Studio 2012 Update Pack 4. Once again, this will take a little while. This installer actually does have a lot of the files already contained in the download, so this one should not take anywhere near as long as the actual installer for Visual Studio to install. Alright, so I'm going to go ahead and install it. And then, like I said, this will take a few minutes to run, but hopefully nowhere near as long as the other one did. Alright, so after you install the Update 4, the next step is actually to install Windows Updates. So you go to Start, All Programs, and then Windows Update. And when you check for updates, it will find a large amount of updates that need to get installed for Visual Studio. So make sure that you run those, do all of the Windows updates, and then when it's done with Windows Update, then you're ready to go. But one word of caution, please make sure that you restart the computer after all of the updates are done, because there are some new files and some new libraries that get loaded, but they only actually get loaded after Windows gets restarted. To launch Visual Studio, there is a link that will be created on the Start menu. The thing that you'll notice though is it's not called Visual Studio, it's called VS Express for Desktop. And if you have a Windows 8 computer, you may or may not be able to find it easily on the Start screen. So the way that you locate it, it's under All Programs, and you will have a Microsoft Visual Studio 2012 and 2012 Express. The 2012 Express is the one that we installed, so you want VS Express for Desktop located here. On Windows 8, your best bet is to actually search for it. So go to the Start menu and just start typing VS, and it will actually locate it. Now, the installer for this, even though it is a free edition for students, it does require for you to register it, and when you register it, they will give to you a product key to use. One of the things that you have to do when you register it is it will ask you if you're a student or a member of an educational facility, and so the answer is going to be yes, you are, and then you can get a product key for free. The major differences between the Express version and the Pro version are that the Express version does not have some of the more advanced publishing capabilities, and it also does not have some of the abilities to share projects with other members. So you want to make sure that you register it. They will give to you a product key, and then you can use that product key to activate Visual Studio. After you type in the product key, you will see a screen that says that it's confirming your activation with Microsoft, and then it will show to you that the product key was successfully applied. And as long as you get this screen, it's actually ready to go. It's ready for you to use. And like I said, just make sure you run Windows updates, make sure that you restart the computer, and then you're ready to go with using Visual Studio. So I'm going to go ahead and close this. The very first time you launch it, it will take a minute for it to initialize everything. It has to get some folders ready for your user account, and every user account that's on the computer will go through the same process where it has to load things to get your user account ready. And like I said, all it's doing behind the scenes is just simply copying over some folders from a default folder location, and it's setting up our folders to store our projects. When everything is finally done installing, it will actually present to you this screen, which is the Start page. And if you notice down here in the corner, it is telling me that there are updates for Visual Studio. So even after you run all the Windows updates, there may still be other updates that the actual Visual Studio program will find for you. So same thing as before, go ahead and run these, keep running them until it runs out, then restart your computer again, and you'll be ready to go ahead and use it. Now that I'm done with the installation, there are some things in Windows that need to be configured. We are going to be using the command prompt to be able to manipulate some programs, and that's how we're going to start off making our basic console apps. So one of the things that I need to do is I need to locate the compiler for C#. Now by default, the compiler is located under the Windows folder, and it's located in a folder called Microsoft.net, inside of a folder called Framework, and then inside of here you'll see some folders that have version numbers. Now this one right here, this 4.0.30319, this is the current version of C# that we're using. This is the actual compiler folder for .NET Framework. So if I go to V4 and do a directory listing, I will see that there is a file in here, and actually I'm going to have to do it a different way, called CSC, and it is our actual compiler. It's called csc.exe. And what's going to happen is every time I open up the command prompt, I'm going to have to do the same thing where I have to go to this entire path to be able to run CSC. And I don't necessarily want to do that. So I have two options. One is I can modify what's called the path statement, which the path statement tells Windows, hey, if you can't find the executable, look in these folders. And if it exists in the path statement, then it will just automatically run the file. The catch is, for me to be able to modify the path statement, I have to modify it for all of Windows for something that I only need every once in a while. So what I'm going to actually do is I'm going to create a shortcut to the command prompt that will automatically create the path to here. Alright, so what I'm going to do is I'm going to make a new shortcut here on my desktop. And what I want is the command line, which it has a Windows variable called comspec. Okay, so this is the same as going to start and running cmd.exe. And then what I want to do is I'm going to issue a command, which is the switch /k, and I want to modify the path statement. And what I want to do is whatever the current path statement is represented by that variable. And then I want to append to the end of it the system root, it's %, system root, which is representation of C:\Windows, and then /Microsoft.net /framework. So essentially that same folder that I was just in, so v4.0.30319. Okay, so what I'm doing is I'm simply making it where this shortcut will automatically open up the command line, and then what it will do is it'll automatically add that path statement. So I'm going to call it cmd with path. And the idea here is that this shortcut, when I open this up, if I issue a path statement, you'll notice that that folder is actually located there. So if I were to type CSC, even though I'm not in that folder, it will actually bring up the actual compiler for me. Alright, now the catch is, notice it opens up in the Windows folder every time it's going to do that. And I don't want it to do that, because what I want to do is I want to be able to create a text file here, which is my program, and compile it, and I don't want to have to keep changing the folder. Alright, so I'm going to modify my shortcut just a little bit. So I'm going to go to the properties, and here it says start in, it says Winder. That represents the Windows directory. I can change that to CD, and what this is our current directory. So now what will happen is if I double click, you'll see I'm under users, my username, and then desktop. And so now I actually am in the folder where my program is going to exist. But if I do a path statement, I can actually run the C# compiler against a file that I already have. What I would suggest doing is create this file, this shortcut, and then save it for later, because every time you create a program, when we make a console-based application, we're going to reuse this shortcut. In this lesson, you learned about the history of computers, you learned about assembly and machine language, what a high-level programming language is and how that helps us as a programmer, about compiling a program so that we can get it into machine language, and the just-in-time compiler, which will actually convert our code into an executable that gets understood by the common language runtime, which will in turn put that into a virtual machine state that actually can interpret it and make the processor understand what the program does. You learn about the timeline of some of the more prevalent programming languages, the history of C#, and also how to install Visual Studio and C#, and then also how to set up the shortcut.